Hello, my name's Gavin, and today we're going to be walking you through mine and Abby Boland's MATLAB project, Welcome to the Matrix. So this is a simple problem, or a program that can help solve system of equations and do stress-strain analysis. And so this was built for students just like us that were in classes like CE204, CE207, linear analysis, and whatnot. Just to help speed up the whole process of solving problems once you've already done the initial analysis of the problem, and it just comes down to computations. So how this works is there's two paths where you choose one option or the other at the beginning, and then the program will store your inputs as it goes and run a few programs in the background to give a final matrix for each version. So first, I'm just going to run through some examples, and we'll do so that we see here welcomes you and asks you which way you want to go with this. Number 1 for system of equations, number 2 for stress state. We'll do 2. And just to speed this up, I have all my values that I'm going to enter in off to the side. So a normal problem would look something like this, where you're given a picture where you would then make a free body diagram of all the forces. You would make a cross section like this, where they're asking for the stress state at this point H right here. And so you would enter in, you would have to already know some of these values, such as A, moment of inertia, polar moment of inertia, but these are really easy values to figure out on your own. So we're going to enter in the area right here. So this is going to be a pretty long process, but that is just how it goes with these problems. Everything that you're seeing right here, it asks for the unit, so you know exactly what you're putting in. And it's just going to take you through every step of the way. So it's asking for area, both moments of inertia. Now we have axial force P, and see it says in newtons there, so it gives you the units as well. I'm going to keep going. This is fairly lengthy, but this would easily take far longer to solve with pen and paper if you already have these values and you just need to solve the final answer. And you do need to input zeros, even if a value is a 0. The program still does need an input so that it can actually do the calculations on this. So we're going through, there's a lot of inputs, just one after another. Except it's always telling you exactly what it needs, in what direction, in what units. Thickness of the cut, T in meters, gives you the symbol it's normally given as is T. Gives you the units as well. Coming up with a whole lot of zeros, so it's going to get pretty exciting. If you don't already have a seatbelt on, I would put one on now, because this is really about to speed up. Here we go. Last couple calculations. Torque, very general reading. We have this there, and here we go. Stress state at point of interest is given by the stress matrix below in units of pascals times 10 to the 5th. So all these values are times 10 to the 5th. This is going to be the stress state X, Y, Z column. And then we have rho X, rho Y, rho Z. And so you can see the stress states in all these different directions. So now I'm going to run through what it would look like to do it the other way if you're going to be solving a system of equations instead. Okay, so I have all these numbers again. Little intro just for the user to learn on their first time how this is going to work. So we have the number of equations. This is going to help the program figure out if there's actually going to be a determinate solution. Here you can see the general form. We used A through I just to keep it in order. We put this here so that everyone will know exactly how to enter in their values. And so the first thing we have is this, where we're going to do entering in exactly as it shows on the computer. I'm just going to speed this up and copy over these calculations. As you can see, it's asking for the second equation and the third equation, and it is coded so that it only asks you for as many as you entered. And then here we have a little array. The variable A equals 2, variable B is -1, variable C is 1. And so it has a nice little display for you at the end. If we were to have an incorrect or an indeterminate system or more than 9 equations, it would tell you to come up with a new system of equations. And yeah, that's it. So you can kind of see how there is some level of initial analysis that needs to be done before this program is run, but once you do have those numbers, it's pretty easy to go from there. Thank you.